Do I need to redraw this figure? This is fine, right? Or if you want better drawings, you can go to the slides of CS 224N. Okay. Or let me just do it once. No, in fact, this is fine. This is fine. I am not doing that. Okay. So let's continue. क्या चीज? एक second. Okay. So we start. So we had done. This was which architecture? Encoder decoder. Okay. But this encoder decoder is using RNNs. Okay, so there is a encoder RNN and then there is a decoder RNN. Now here what you are doing is you are using attention with RNNs. Okay, so what were the three problems we were talking about that RNNs usually suffer from? First is vanishing and exploding gradients problem. Second is there is too much emphasis on this one vector. So there is too much responsibility given to this one vector. This should encode the whole sentence, right? It should encode sufficient information that decoder is able to decode the whole sentence for whatever reasons it is using it. Now, what was the third thing? That RNNs, they process input sequentially. Right. So H2 can only be computed after computing H1. So in general, HT can only be computed after computing HT minus 1. So that's a very much limitation that basically doesn't let you use your GPUs as effectively as you could have done it otherwise. Okay. So what did we do? What is S1? What is S1? This is the hidden state. So this is the hidden state for decoder. Okay. Now what? You are going to take dot product of this hidden state with all the other previous ones. So here there are only 4, but if there were 40, you will take dot product with 40 of them. Okay. So in that case, this vector will be of size 40 cross 1, and then what do you need to do finally? Yes. So once you have got these 40 numbers, you are supposed to take softmax. So you have these attention scores out here after dot products, right? So 40 numbers, because I said there are 40 units now. So you will have 40 attention scores, take softmax of them, that is going to give you a probability distribution. So rather than saying ki just depend on one word, it gives you somewhat dependence on everything, but more it doesn't have to be so, but usually more attention to some particular word, right? So do you think it can happen that where it gives kind of equal attention to more than one word? Is that possible? Roughly equal? So let's say what I get is I get attention output of this kind. Is this possible? Of course. I mean, what stops anybody? Can you give me an example? Example is here only. Here on this board you have example. Right. So this is Entarthe. No. Right. So all of these words will give high weightage to Entharte, but not equal on 3. See, if you are translating from English to French and this word Entharte is supposed to come out, in that case you will put equal emphasis on hit with a pi, because hit with a pi means, so basically this thing, there is nothing special about this, so I don't even want to have it here. Alright, so we have computed attention scores, this 80. So for S1, whatever we computed using S1, this is called A1. What are the dimensions of A1? What are the dimensions of 80? 400 cross 1. Why 400 cross 1? 4 cross 1? 4 cross 1, 400 cross 1, what else? 300 cross 1 I also heard. Sorry. Input vector is 300, x's are 300 cross 1.
सर वो डॉट प्रोडक्ट लेंगे तो वो स्केलर आएगा, स्केलर को अपन 4 उसमें डालेंगे तो 4 क्रॉस 1 होगा सर, 4 क्रॉस 1 में
No, but this 80 was something else, yaar. 80 is this guy. See, these are my attention output, okay? But 80 is something else.
200 क्रॉस 1 होगा क्योंकि वो 100 क्रॉस 4 से मल्टीप्लाई करके 4 क्रॉस 1 it is.
See, how do you write 80 like this? Good that I have not written it here. So I equal to 1 to tx, because I will go for all tx, and then alpha I, what else? H I. Okay. So this will be 100 cross 1. See, all hidden states, they will be 100 cross 1. Why 100 cross 1? Because in our case we are always saying H is 100 cross 1, S is 100 cross 1. If somebody wants to keep it a different size, then that is up to them. Okay? Huh? How is 4 cross 1 correct? Alright, so okay, now, how do I still compute y hat? So this is 80, this is ST, what do you do? No, right, so there will be a T here as well, na? Because what we just computed was just A1, right? So there will be T here because this can go for all these things here. Now, so tell me, how will we compute y hat now? Y hat will be a function of y hat will be a function of 80. So what are the dimensions of this guy now? What are the dimensions of this guy? 200 cross 1. Okay, why 200 cross 1? 100 coming from here and another 100 coming from here. So now what do we do for y hat? Y hat is a softmax. I mean, the activation at this layer is softmax now because you want to get an output. So you will have something like, and since we are generating, so this is language modeling. So what will be the size of my output layer? Mod V cross 200. क्या चीज? See, so we have talked about this so many times. Deep learning is mostly about your imagination, right? But not your imagination alone. It has to be backed up by the hard work of actually evaluating, programming and proving it. Okay? So, AT is 100 cross 1, ST is 100 cross 1. Now, when here you are computing y hat, will you take S1 into account? So that you are keeping, okay? But you have done all this math because you want to, put some emphasis on these vectors as well. So what AT is basically giving you, you should give maybe 0.4 times this one, 0.2 times this one, 0.1 times this one and remaining times this one. So this information on how much emphasis should be put on which H in the encoder part is captured by AT. So what people have done in this case is that my output earlier here y hat, which was just a function of ST, is no longer just a function of ST, but it's a function of AT and ST. Now when you want to say it's a function of AT and ST, what you could have done? You could have done simply AT plus ST, right? But they don't do this. They keep these two things as separate features. So I am pretty sure they must have tried adding these two, and this gives you better results, and hence that is your choice. Yes.
सर इससे जो अपन समीशन लिए कि अल्फा और बीटा सर इससे मतलब वेटेड जो अपना अपन पैरामीटर्स बता मतलब हिडन लेयर को इनपुट दे रहे वो वेटेड कैसे रहेगा क्योंकि अगर अपन A1 और A2 की बात करें तो वो एक दूसरे से डिफरेंट कैसे रहेंगे?
Sorry.
मतलब सर अपन ने A1 कैलकुलेट किया.
How will A1 be different from A2? बताओ.
सर A1 के अंदर
S2 in general will be different. Even though my H's remain same, but S2 in general will be different.
तो सर प्रोबेबिलिटी डिस्ट्रीब्यूशन तो वही है.
No, I take dot product with S2. These numbers will change. These numbers will change. I take softmax, numbers will change.
तो फिर सर समेशन ले क्यों रहे हैं अपन सीधे मतलब A1
This one?
अल्फा 1 और H1 को मल्टीप्लाई करेंगे.
See, alpha 1 H1 is already being multiplied here. So what we are saying here is something like, so let's say this number is 0.5, this number is 0.2, 0.1 and 0.2. So what A is capturing is 0.5 times H1 plus 0.2 times H2 plus 0.1 times H3 plus 0.2 times H4.
और सर अपन ने तो समेशन ले लिया सारी चीजों.
तो plus, I have been saying plus throughout. हाँ.
तो सर वो कैप्चर कैसे करेगा एक चीज को पर्टिकुलर?
See, that's what I am saying. Here, you think it does not capture. Someone else thinks it captures. That someone else writes a program and shows you this works. Okay. Now, what you are saying is what should capture then? Just alpha 1 H1? No, see, why just, I mean, you want to take, so this is more logical thing to do. You want to take output here and you want your output to depend on everyone, because you don't know which of these guys will help you get a good result here. So you take weighted average of everyone.
Generalized particular submission.
Right. So sometimes this number will be higher, but sometimes this number will be higher. I mean, just doing one will not make sense, because which one to take then? It is like you are querying here. So this guy is questioning whom should I depend on? And the answer comes, you should depend 0.5 on this guy, 0.2 on this, 0.1 on this, 0.2 on this. So it is not saying you should not depend at all on any of it. And in a way it makes sense, because in the end you are trying to translate this whole sentence. So these words, they are not independent of each other. They have something to do with each other. More questions? Right. So this, I mean, for computing y hat 1, you will consider ATA1 S1. This one? You just answered the same question. So, what are alphas? Numbers between 0 to 1. Okay? And they sum to 1. So, summation alpha I is equal to 1. All you are saying here is, while outputting y hat here, you depend 0.5 on H1, 0.2 on H2, 0.1 on H3, 0.2 on H4, right? So you are not saying just depend on H1. See, when you are translating something, in the end you are supposed to look at the whole sentence. You can't just translate word by word. That's a bad idea, right? So in a way this matches with all intuition that we have, that okay, I want to translate this sentence, so I need to take care of all the words while outputting whatever here. But is there a word I should pay special attention to? It turns out you should pay special attention to this one, because you are literally translating this word. देखो, when you are doing things at this big scale, you have hundreds of millions of sentences, right? So there are underlying structure that we are not able to think how will the system do it, but it turns out it does it well. So there is no theory that can prove that this should work, right? You have to write code for it, execute, and show that it actually works. So I can't, that's why I mean I couldn't ask you, very theoretical questions in your midterm, because there is nothing like prove that this, there is nothing like derive this. There are no derivations, there are no proofs. What is HT? No, this is fine, I think, right? Huh. What are you talking about? ST or HT? S is the hidden state of the decoder. Right.
हर बाइट के लिए बनेगा ना?
Of course. See, you had ST for everyone anyway. This extra thing is AT. And AT is that vector which is, yes. And this is capturing how much weightage should I give to each one of the encoder states. S2, yes. S1, no, S1 is done. See, S1 was used to compute S2. So you can just throw away S1 now. In reality, not because when you will do back propagation it will be used, but for all the forward computations, yes. More questions? See, ask as many as you can because this will help me later. This is probably the most important notion in this whole course. If you don't understand attention, then you are lacking something. Okay? So even if you ask me whatever number of questions, that is fine. Actually, I should have been better. I mean, ये क्या है बगल में? But ठीक है. So I should have done it on a completely, पता नहीं इस डिजिटल में भी क्यों कंजूसी करनी है? तो डन? चलो. All right, so I hope you get the whole intuition. Okay? All right, now let us start writing the equations. And this thing is so important that I won't even mind writing everything here. So what are the decoder hidden states for us? From thank you. So encoder hidden states are H. So H1, how were we writing it? H1, see this is the problem, I mean HTX. Now in slides they are using N, okay, and they are using subscript. Now at time step T, what is this? At time T step, at time step T, decoder hidden state is ST. Okay. Now, what are the dimensions of these guys? But in general, what we can write? Let's say this is some R to the H as they are using. Yes. So what will be ST? What do I do here? H. Why H? Can it be different? What forces this must be H? Dot product, right? You need to take dot product of these two. But what else you could have done? I mean, see, you can do all sorts of things. Right now you are saying you want to take dot product, so it should be like this. At some point in time later you can say, see, we want to do something else, we will do that and then later do dot products. Okay, so you can do whatever. Right now we have chosen this. What else? So so we get attention scores. Now so attention scores ET for this step. How do I write? How do we write ET now? But it seems I'll run out of this board too, but ठीक है. Yes. What is ET? See, we are just writing what we have done in last 1.5 lectures. Okay. So ET is. So what is ET first of all? Attention scores. What were attention scores? Dot product. Okay. So we just take dot product. Sorry?
Attention scores alpha K or P?
No, attention score was first, then we had something else. We had attention distribution, which were alphas. Okay. So again I need to see how do I write? अपनी notation में क्या था ये? S. So we are at timestamp T. So this was ST, and then we take transpose of this. So you take transpose of this and then you dot product with H1 that is fine, same thing, right? So shall we do that जो अपन कर रहे थे? Okay. Now what will be the next guy? I don't want to be. So just help me write the last one. ST transpose. This guy remains the same. Dot HTX. यार ये क्या है? हाँ बट ये खुद अपने आप में टेढ़ा है यार. Okay. This is fine, right? So this is now. So what is the dimension of this vector ET now? TX? right? Okay, what is the next that we are computing? So, see, Itidan yoga if I do it this way, yes. So, now compute softmax to get the attention distribution now what is the attention distribution? Alpha t and it is again, see t means it is for this time step. So, alpha t is softmax of Et. So, what are the dimensions of Et now? Sorry, alpha t same as right. So, same as Et. Okay. So, this is same as okay. What next? What are we supposed to compute next? Et. So, what were we calling that? So, attention output. So, now attention output AT, right. So, to get attention output AT, what is it? What was AT? So, summation will go from, so एक second. Et summation will go all the way to Tx, it will be alpha I, वे अपने अल्फा को कैसे लिख रहे हैं यार? Is this right? So, I goes from 1 to Tx, alpha I, what else? Okay, this one na? Ha. So, this one and H and so H I, yes. So, this makes sense, and AT should AT, what are the dimensions? Same as, but what should I write here? Tx, H, right. So, see, this is a scalar and these guys are coming from RH, okay. So, this is RH. AT, because HI was 100 cross 1. Now, this is scalar. What is left now? So, your y hat is a function of your y hat is now a function of which vector? AT right? And this guy belongs to, I mean decoder is fine, R2H. So my y hat is a function of this one. So what does it mean if I am doing language modeling? What will be the dimensions of my final this layer? Mod V cross 200. See, you will have something like mod V neurons here and then 2H neurons here. So it will be like mod V cross 2H. So we are done with ekdam plain vanilla attention. Okay. Now we need to, no, see LSTM is almost out of picture now. So what else can you do on this? So let me write, so they say attention is great, attention significantly improves the neural machine translation performance, attention provides more human-like model of the machine translation process, attention solves the bottleneck problem. Which is the bottleneck problem? This one vector capturing everything. Okay. Attention helps the vanishing gradient problem. Attention provides some interpretability, because if you are providing, if you are attending to one word more than the other, then it gives you some kind of an interpretability too. So attention is actually a win-win when you compare it with RNNs. Okay, it does not hurt anything at the RNN level. It only adds up. Okay. Now question here is, can you get rid of RNNs altogether? And this question was first answered by Attention is All You Need, 2017 paper by Google. So Google's paper have been awesome in this area. They somehow just didn't do one thing, which is GPT. Okay. Okay. So I'll take a pause here if any questions. Though there is nothing new that we have done in last whatever minutes. Okay, we have just repeated what we talked about. So then I ask, compared to encoder decoder architecture, how many extra parameters have we added due to attention? See, I strongly encourage you to follow up CS224N as well. So once we are done with the lecture, right, you should go and watch. Okay, you can watch previously too, but I think it will make more sense if you watch it after our classes. So how can we, how many extra parameters are added due to adding attention? So let's start from here. When we say parameters, what do we mean? We mean learnable parameters. Okay. So how many extra parameters are you learning here? These guys? You were doing previously? These guys? You were doing previously? What about this guy? In fact, why am I answering? I am asking this question. Yes. हाँ, how many parameters here? T or H? Sorry, Tx you said. So how many learnable parameters here?
Small t into tx. Small t into tx.
0. Where are the learnable parameters here? You are just taking dot product. Okay, so 0 parameters. Again, now this should give you hint. How many parameters here? So in softmax there are no parameters involved. All you do is compute e to the power the first one divided by sum of e to the power of all. Okay. So again no parameters here. What about this guy? Computing this one now. How many parameters this time?
जब कैलकुलेट करेंगे तो
Wait. No parameters? So no parameters here because this is what you know. This is so all these are numbers to you, right? You are not learning anything here. So even to compute 80 until 80 there are no parameters. So attention is giving you a lot of power without really increasing the. I mean, of course it is increasing because you are doing something that you are not doing, and in particular for every word in the output you are attending to every word. So it is increasing a lot of complexity, right? But no cost for the parameters. So that's a huge gain. So can we say that attention gives you a significant advantage without increasing the number of parameters compared to my RNN encoder decoder architecture? Can we say so? Yes? Yes or no? Right. So then here we have 2H. In plain RNNs you had just H. So the number of parameters have actually increased by how much? Mod V cross H. That many parameters have increased, but that's not that big a deal, right? I mean, so let's say, how would you do? So let's say if this was really a big deal, as a deep learning engineer, what will you do? You will say, "Kisi, dekho, this is increasing too much complexity. I will not concatenate this. I will just add up these guys, okay? And then H here, mod V here, without any change." So even if you don't concatenate and just add, right? It might so happen that you get, without increasing even a single parameter, you get performance increase over the plain encoder decoder architecture for RNNs. Okay. So we are done with the attention, I mean the vanilla part of it. Now, so since we have said there are no parameters, where do you think I can add parameters? So before I forget, they are saying A is sometimes also called as so it is also called as context vector sometimes, and this makes sense because it is giving you context, how much to depend on which one. So what is F guys? So सब मैं ही करूँ यार, है ना? So what is this F? this y hat t will be softmax of w this one. So what do I call this? W y a. Now this becomes w y a comma s. So very good, thank you. So no, I'd like to put this one. Okay. Now what now? AT ST. Done? लगाते रहो. So BY. Oops. Right, so now I want to introduce parameters. Don't worry, but we will introduce anyway. So okay, just simple thing. Oh, so right now we are writing E as, so I am not writing any superscript subscript, we are writing E as S transpose SH, right? Where can you introduce parameters here? So we'll just talk about the idea and then formally we'll start doing in the next class. See, this is what you are doing. Now what happens if you start doing this? What is the effect of this? We answer this and we go. So S comes as it is from decoder. What we are saying, don't depend on H as such. Rather, what do you do? Learn parameters W. So what will be the effect of this? Give me the dimensions of W first of all. So this guy is RH. This guy is RH. What about this guy? This is a scalar. We are talking about just one entity right now, dot product thing, right? So this is a scalar. What should W be? What should be W? It can be, but let's not keep it. So it can be scalar, there is nothing wrong with it, but let's not do that. Yes? What should this whole thing be? RH. So this guy must be RH cross H will give you RH again and then take a dot product. So what are we saying here? Don't pass the original H's for dot product with S. Rather what you do? Parameterize, right? Make your network learn some parameters and maybe improve what? Maybe improve H for this purpose and then go ahead. It turns out that This gives more flexibility to network and hence works better. Rest we do in the next class. So we'll start from here. Questions? Sorry?
दोनों साइड में फिर जो h के लिखा तो h क्रॉस 1 लिखना चाहिए ऐसा
Say that again.
सर जो अपन ने
एच का है वो RH क्रॉस 1 बोल रहा है कि RH क्रॉस 1 लिखना चाहिए
केवल h की जगह RH क्रॉस 1 ऊपर ऊपर
RH cross 1? No. नहीं नहीं नहीं, you don't do that. See, आप ये कब लिखते हो? आपने ये मैट्रिक्स बनाई, वहां पे आप लिखते हो दिस इज ए वेक्टर स्पेस, दिस इज ए h डायमेंशनल वेक्टर स्पेस. सो बाय डेफिनेशन हर एक वेक्टर विल बी h क्रॉस 1.